I'm Reinier Vanderlee, and this is my vineyard, the Vanderlee Vineyard. And this is the place that was the inspiration to develop the Vinduino soil moisture system that helps me save 25% irrigation water each year. In order to measure soil moisture, you can use commercial sensors like the Watermark SS200, but they will cost you around $40 each, and you can make your own for about $1 using plaster of Paris gypsum and common components like machine screws like this and a window mesh. So the way you put it together is you put the screws here, you have two plastic spreaders that keep the distance, put the mesh around it and then put it in a cast like this. So this is a 3/4 inch PVC coupler that I use as the mold here. You pour in the plaster of Paris. You make sure that there's no air bubbles trapped inside. Wait till it's cured and then you take it out. Now we have the sensors, and next is, of course, we need a reader for that. This is what I put together. So this is the Vinduino handheld reader. It's designed to fit in this poly case box. The window for the display is something that you need to cut out yourself. But apart from that, which is the most laborious work, the electronics, the putting together the electronics is relatively simple. The PCB is already available, and what you need on electronic components is relatively limited. 3 resistors, 2 diodes. There's a potentiometer here to set the LCD contrast, and then there's a screw-on terminal for the connector wires. That's about it. Oh yeah, by the way, I forgot the battery connector. So, it's a very simple design to build. So now we have the reader and we have the sensor. Let's put them together and put them to work. So you recognize this from the previous chat when we were building the sensor. So the 2 electrodes are here, and when I put them in water, let's switch the sensor, the reader on. When I put them in water, you'll see that the impedance immediately changes, and the deeper I put this in, now it gives me 100%, which is actually pretty close to what the situation is. I put in a little a calibration curve in the microcontroller, so it converts the resistance of the sensor into a percentage of water content. We can do the same with the sensor. So the sensor basically is the same as the 2 electrodes that I'm showing here. It just has the addition of the gypsum around it, and the gypsum is intended to make the sensor sensitive to moisture only and not to salinity in the soil. So in order to determine how much water is in the soil, I connect this meter to varied sensors, and by activating the meter I can actually read how much water is in the soil. In this case, the moisture is 74%, enough for this vine.